In the fifth question, we have sine cube x into cos cube x. How do we deal with this one? So sine cube x, cos cube x can be taken care of using, there can be various approaches. One of the approaches is that I observe a sine x into cos x power 3, right? So sine x times cos x can be written as, I can write sine x times cos x as, please observe, sine 2x by 2, and there will be power 3, right? So one of the ways could be that I write sine x times cos x power 3, and this will convert to sine 2x by 2 power 3, okay? And this is actually, okay, this is 1 by 8, okay, that's okay, sine cube 2x. Now I can integrate sine cube 2x since I've just seen in the previous question how to integrate this kind of expression, right? So there were two approaches to follow after this, right? That is, we can use the formula for sine 3 theta and write it in terms of that, or we can directly separate sine square 2x and cos 2x, sine 2x, and we can use substitution over there. Can we use some kind of an idea, similar kind of idea, that first method which you used in the previous question, can we use a similar kind of idea over here also? Maybe. So we have sine cube x, cos x. Can I take one cos x separate? Can I take one cos x separate? Yes, maybe. I can write this as sine cube x into cos square x into cos x. Okay, so what do you want to do with this? What I see is this cos x is nothing but the derivative of this sine x, right? Okay, so I can assume, I can substitute sine x equals to t, and the derivative is present with sine dx, right? And that substitution will help me, yes? So let sine x equals t. That tells me that cos x dx will be equal to dt. Now with the help of this substitution, I can write I equals integral of this sine cube x is actually t power 3. Cos square x is nothing but 1 minus sine square x, right? So 1 minus sine square x, which will be this, and cos x dx will be dt. This is what I get. Is that okay? Yes. This can further be simplified as t power 3 minus t power 5 times dt. Yes or no? Yes. And this integral is pretty simple now. This integral will be t power 4 upon 4 minus t power 6 upon 6 plus constant of integration. Now what is this? This t is actually sine x. So this is 1 by 4 sine power 4x, right? Minus 1 by 6. This becomes sine power 6x. Okay, plus a constant of integration. This is what I get, and that is my required answer for this question. But why only this approach? Could I have solved it in any other way? Yes. Oh, there was another way. No, I am not talking about that. That is there, yes. That is one of the approaches that we can follow. So this was first approach, this is second approach, and even here we had two further approaches, yes. And now we are looking at another approach. It's not very difficult, I suppose. You understand this one, right? Here I have taken this cos x separately, yes. I could have taken sin x also separately and used the substitution cos x equal to t, yes. The overall answer that will be obtained will be in terms of cos x there. Let me show it to you. What about this one? Will you not solve this one? No, I will not solve this one. This can be left to you, right? I have left it for you. So you can solve this if you want. You can solve it using this approach. We have already practiced quite a few questions of sine cube x for you, right? Let's deal with this one by integrating with the help of cos cube x can be left as it is. Sine cube x can be separated out as sine square into sine x dx. And I can use the substitution cos x equals t. What does that tell me? If cos x equal to t, the derivative of cos x is minus sine x dx equals dt. So sine x dx will be minus of dt. Therefore, I is equal to integral of t cube. Okay. Sine square x is 1 minus cos square x. Sine x dx is minus dt. Okay, this becomes t power 3 minus t power 5. There's a minus, so this becomes t power 5 minus t power 3 in the bracket and the integral with respect to t. The integral of t power 5 will be t power 6 upon 6. Integral of t power 3 will be t power 4 upon 4 plus a constant of integration. This is 1 by 6. T power 6 is equal to, t power 6 is cos power 6x minus 1 by 4 cos power 4x plus constant, and that is the required answer for this question over here. That's what you have. So this particular answer and this particular answer should be same. Yes, they are exactly same. That's what we mean to say by this expression, right? They're exactly same, and this or this can be left as the correct answer. Both the approaches are correct. Similar approaches, right? Not very different. You can see. That's all in this particular question.